I think I am live now. Can someone confirm if I'm live or not? Okay. Okay. Boring problem, just my opinion. No, Abhishek, I don't really think today's problems were boring. They were really good, I would say. Like in terms of cook-off, like in terms of past cook-offs, I think today's contest was nice. Okay. Dipansh says, when is it starting? It has started now. Okay, cool. Okay, let's wait for a minute or two and let's let people join. I don't see many people, though I think it's more because of the time. Okay, cool. But yeah, let me just tell you a little bit about myself. My name is Naman. I am working as a software developer at Adobe. Before this, I was working in D-Shop. I am a 2020 graduate. I am a candidate master on Codeforces and a 5-star on CodeShift. Okay. And right now, let me tell you some things about CodeShare Unacademy's subscriptions. Okay, so Unacademy has started various batches. These are the 4 batches that Unacademy has recently started. The interview batch started on 17th May, and apart from that, Summarize started on 11th, Adroit started on 3rd, Gladiator started on 3rd. Okay, so and these are the various structures of the program. So if I show you like in Summarize batch, these are the like complete structured path, like how in which week what topic will be done. Okay, so you can just look into this, pause the video and look at. Okay, after that, this is for the interview batch, uh, and then these are some of the educators. As you can see, these are all from like ACM ICPC World finalists or working in good companies. Then these are the pricing. So I'm sure you must be knowing about this already, and as you can see, 12 months is the best one because it gives you per month cost very less. And obviously, you can use my referral code, which is NBYT, and this is going to give you a 10% discount. Okay, so make sure to use my code if you are thinking of buying the subscription. All right, cool. रणवीर says हाँ भाई लेवल काफी अच्छा था पर लग करने में okay. Maharaja says solved 3. Nice, that is a good number. Okay, I would like to know from others as well, like how many problems you were able to solve in today's contest. And in the meanwhile, I'll also tell you like the problem that we are going to solve today. Okay, let me open up the browser and make it big. Okay, cool. So we are going to solve a marathon, vaccine drive, the last problem, chef and subarrays, permutation swaps, and we are also going to solve double burgers because I saw in Div 2 it has the number of submissions of this double burgers is above permutation swaps. Okay, I am not going to tell the solution of falling 0. The reason is because I myself did not get enough time to solve this problem. I was able to solve these 6, like 5 of these and double burgers, but I could not get much time for solving this. Okay, so yeah, these 6 problems we are going to solve. After the stream, I'll also put the timestamps as well. Okay, so you can look from them. Okay, so we only have 9 watching, and the reason is because it's 12:30 in the night. But anyways, I think we should start now. Okay, so let's move on to problem first, which is marathon. Okay, so in this problem, Shiftland is holding a virtual marathon for the categories 10 kilometer, 21 kilometer, and 42 kilometer. So we have 3 marathons. One is 10 kilometers, one is 21 kilometers, and the other is 42 kilometers. Okay, so the last one is 42 kilometers. Okay, all right. And the prices are A, B, C. So for 10, it's A, for 21, it's B, and for 42, it's C. Okay, cool. In order to claim the prize in a particular category, the person must cover the total distance for that category within D days. So we have D days. Okay. So in total, we have D number of days. Okay. Also, a single person cannot apply in multiple categories. Okay. Given the maximum distance D kilometer that chef can cover in a single day. So chef can cover D kilometer per day. Okay. Find the maximum prize that chef can win at the end of D days. If chef cannot win any prize, print 0. Okay, cool. So as you can see, there are D days, and in one day, the chef can cover D kilometers. So if we multiply this D by this big D, we get the total kilometers. Okay, so this is the total kilometers that the chef can run. Okay, now we just need to see. Now, chef wants the maximum price, and we are given that C is greater than B and B is greater than A. Therefore, we will check if this value is greater than equal to 42. If it is, then C is the answer. If it is greater than or equal to 21, then B is the answer. If this value is greater than or equal to 10, then A is the answer. If it is lesser than 10, then we can say that 0 is the answer. Okay. So I don't think there is much to do. So as you can see, the total value is 1. So wait, yeah. So as you can see, like in this one we have 10 kilometers. Okay. So in this one we have 10. Total distance will be 1, and it is less than 1 or 10. Therefore, we'll have 0. If the total distance is 10, 10 into 1 is 10. Then the answer is A, which is 1 in this case. If 10 into 3 is 30, and 30 is actually greater than 21, so the answer will be B, which is 2. Okay, so let me just show the code. Okay, we have, okay, cool. So this is the code. I have scanned the variables D, D, A, B, C, and then I just found the value, which is the total distance, and then I checked if it is greater than or equal to 42, then C, otherwise B, otherwise A, and 0. Okay, I don't think there is much to show in this one, and I think it's clear to everyone as well. I don't think there, like, I hope everybody was able to solve this one. Okay, cool. So the test case running fine, but while submitted, it shows wrong answer. That is what happens with everyone. Ayush Patil, bhaiya jaldi se third discuss karo. Ayush, we will get to the third. I think you're talking about the last problem. We will move on to that. Okay. Now let's come on to vaccine drive. Okay. So let's just erase this. Okay. All right. So in the problem, we are given that suppose the population is divided into age groups 1 to 10, 11 to 20, 21 to 30, and till 91 to infinity. So we have an age group from 1 to 10, then we have a group from 11 to 20, then we have from 21 to 30, and so on till from 91 to infinity. Here infinity is because like the maximum ages are not rare, they are rarely greater than 100, so we have infinity here. Okay, the age groups are numbered from 1 to 10, so this is group 1, this is group 2, this is group 3, and this is group 10. Okay, the COVID vaccine drive has started and people will be vaccinated in the decreasing order of their age groups. Suppose P people are vaccinated per day, and if less than P people are left in the age group, then the remaining doses for that day are given to the people of immediate lower age group, and the process for that day continues until the vaccines for that day are finished or the entire population has been vaccinated. The selection of a person from a given age group is done randomly. Given XP and Chef age group G till the, okay. So basically we are given that P vaccine per day. So in a day, P people are vaccinated. Okay, let's say, okay, and the vaccination is done in this order, that first the 10th group is taken, then the 9th group, then the 8th group, and so on. Let's say that this group had 4 people, this group had, okay, let's take a test case only. Okay, so which test case? Okay, let's take this test case. So this test case tells us that, so basically in this 5 is, I don't, okay, 5 is the age group, so 5 is the age group of Chef age group. Okay, then this 2, what is this 2? This is, okay, let's see what is this. We have P, okay, this is 2 for now. Okay, then, okay, they have said that the last group has 2, then this is 2, then, okay, I need to write them, 9, 8, 7, 6, 5, 4. Then for 8 also we have 2, then for 7 also we have 2, then for 6 we have 3, for 5 we have 2, and for, yeah, so on. Okay, cool. Now we are given that Chef is in the 5th age group, so basically this is Chef. Okay, and we are given that P vaccines are done every day. So this age group will be completed on day 1. So let's write day 1. This will be done on day 2. This on day 3. This on day 4. And now when we come on to this age group, we say that it is done on day 5. But there is still one vaccine left. One person left. There were 3 people and only 2 vaccines. Therefore, one person was left. Therefore, that one person and one person from this age group was taken. So basically, day 6. in day 6 we were able to take one person from this age group and one person from this age group, and then day 7 will be for these two age group, that one person, the leftover one person from this age group and the one person from this, and so on. Okay, now chef is in this age group. The best case for him is that whenever they are going to vaccinate in this age group, chef is the first one standing. Okay, so basically when we were on day 6 we took one person from this age group and the rest one person was taken from this age group, which was chef. So basically the minimum answer will be 6. Now in the worst case, chef is standing in the last, like at the last position in the line. Let's consider that there are like x number of people, and to get the best answer chef has to stand in the like front direction. To get the worst answer he has to stand in the like very behind. Okay, so if it is he's standing on the very behind, then on day 6 the other person will be chosen and chef's turn will come on day 7. So the minimum is 6 and the maximum is 7. Now how to do this? Okay, so basically what we are going to do is, first we are going to find the position of chef in the minimum case and the maximum case. So if we see the position of chef in the minimum case, so basically chef was standing 2 plus 2 plus 2 plus 2, which is 8, plus 3, which is 11, and then chef was standing. So basically chef was standing at 12th position. Okay, let me write it here. So his position was 12th for minimum. Okay, and for maximum his position was 13, because basically what we did was, for finding the maximum we did 2 plus 2 plus 2 plus 2 plus 3 plus 2, which is 14. Then we know that, okay, sorry, yeah, this is 13. Okay, and since he is the last person, therefore 13 will be his index. Okay, if we have to find the best value, we found out the summation of all the values before him and then we added 1 to that. Okay, so that is how we got 12. Now we can just find out like on which day this will come. Okay, so now how to do that? So basically if it is 12, we know that we can just do 12 by 6, which actually, sorry, 12 by 2, which actually gives us 6. Okay, now if we do 13 by 2, this gives us 6.5. So this 0.5 tells us that he will be vaccinated on day 7. Now how to handle this in code? So basically there is a very small like technique which I'm not sure like how many people know about it. So basically if we have to find, let's say, x by p. So basically if we have to find in which index this x is to come, if we divide it by p, we know that if x percentage is, so okay, let me do it, like let me give an example only. So let's say if we had to divide 13 by what do we say, 4. 13 by 4, if we do in an int, it gives us 3. But if we see this 13 is actually in the 4th quarter, so what we do for that is 13 plus 4 minus 1 by 3. This will give us 4. Now someone will say, what if this was 12? If this was 12, then 12 by 4 was supposed to give us 3. If you do this for this as well, so basically if we get 12 plus 4 minus 1, which is, this comes out to be 15. And if we divide this by 4, sorry, this was 4. If you divide this by 4, this again comes 3. So this is a small like technique I think some people might not be knowing. So basically what you do is sum minus p plus 1 by p. This gives us the index where this sum is going to lie. Now let me show you the code, so how I did this. Okay, so if you look at the code, I'm just scanning all the values of every age group. Okay, then what I'm doing is I have a left value and I have a right value. Right value is actually the best case scenario and left is actually the worst case scenario. What I did was, I knew that G is the age group of chef, so I added every value from 10 till G. Okay, so I have that value in left also and right also. Now we know that for finding the best case, we just had to add plus 1. And for finding the worst case, we have to add this age group, the size of this age group as well, because the chef is standing at the very behind. Okay, so we have the left index and the right index, which are the best case and the worst case. Now I'm just doing is right plus p minus 1 by p and left plus p minus 1 by p. This is going to give me the section in which the chef is going to come. Okay, so I hope this is also clear to everybody. Anybody run 4th? Okay, Ranveer Singh, भैया इसे prefix sum से कर सकते हैं क्या? Not prefix, we are actually using suffix. We could have also taken like prefix then divided by total sum, which is actually suffix only. So we are finding the suffix sum. Okay, okay, I hope this is also clear to everyone. Again, there was much to do in this one. So I assume everybody's okay with this. Okay, cool. Let's move on to the next problem then, which is the last problem. Okay, cool. I don't know why there are more submissions in the last problem and less in chef and sub arrays. I feel chef and sub arrays is easier than last problem. But anyways, let's move on to last problem and let me rub everything. Okay. 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 Clear. Okay. Maharaja says clear. Okay, cool. I don't see many people responding in the chat, and that actually makes things very less interactive. So I would like if people can like write something in the chat to let me know if they're clear about the approach or not. Okay, cool. Let's move on to the next problem. So basically what we are given is Deep wants to become a, okay, this is some background story. In this problem, you're given a matrix that extends infinity to the right and down, okay, filled with values as shown below. So basically, this is a matrix that we're given, and this is extending till infinity, okay. And so let's see what we need to do. Let xy denote the cell in the xth row and the yth row. The upper left cell 1 1 contains an integer 1. You begin to at the cell x1 y1 and must walk to the cell x2 y2 by only moving right and down formally from the cell xy. In one step you can move to cell, okay. So basically we can only move in the downward direction or in the right direction, okay. Okay, cool. Okay, let's generate the, what do we say, matrix, okay. So I am taking a rather bigger matrix, and let's first see like what are the patterns that we can observe in this one, okay. Okay. Maharaja says last problem solved, it took most of my time. Okay, cool. This is a little bit on the implementation side, so it's okay if this one took time. Neelu says hi bhaiya, is clear. Okay, cool. Ranvi says clear. KJ, आज short contest में heavy cheating हुआ. Okay, cool. I don't really know like where this cheating was happening, but do let me know in the comments so that I think it's Telegram only then. Okay, cool. So let's fill this matrix. So we have one here. Okay. We have 1 here, we have 2 here, we have 4 here, we have 7 here. This is 3, this is 6, this is 10. This is 5, 9, 8. Okay. Now, let's try to see the pattern which is here. If you see, the difference between 1 and 3 is 2, 3 and 6 is 3, 6 and 10 is 4. That means the next difference is going to be 5. So let's write 15 here. Okay. Similarly, here as well. The difference here is 3. Here the difference is 4. The next difference will be 5. Therefore, let's write 14 here. I think it will, yeah, okay, cool. Now, similarly in these as well. Okay. Now let's move in the horizontal directions. If you see, this has a difference of 1. This has a difference of 2. This has a difference of 3. Therefore, the next value will have a difference of 4. So, this will be 11. And similarly, this has a difference of 2, this has a difference of 3, and this will have a difference of 4. So therefore, this will be 8 plus 4 is 12. So I hope the pattern is clear to everyone. Now let's forget the problem and let's first try to solve a simpler problem. Let's say I give you any coordinate xy. I want you to find out the value which is present at that particular x and y. So let's just try to find any random xy. Let's say this xy is 3, 4. What is 3, 4? So basically this is 1, 2, 3. This is 1, 2, 3, 4. Then 3, 4 is going to be this value. Let's try to find out this value. Okay. Now, okay, cool. Let's see. So basically, how to find this value? To find this value, we first need to find out this value. Then we know that we can just increment. Now, how to find this value? We know that this value is actually going to be equal to, okay, I need some space, so I'll rub this part. Okay, and I will also move my video to the other part. Okay, just a second. Okay, cool. I hope everyone can see this, see the video now. Okay. Now, let's see what is happening. Okay. So if you see, this value is nothing but, so if the index is 3, this value is nothing but n into n plus 1 by 2. Because if you see, we had 1, then we added 2 to it, then we added 3 to it, then we added 4 to it. So this is nothing but sum of the first n numbers. Okay. So this value can easily be found out by n into n plus 1 by 2. Now we need to find out what is the increment in this place. Okay. Now how to find that increment? If you see, here we had an increment of 1, here we had an increment of 2, here we have an increment of 3, which is nothing but this index. So basically, in every iteration, we need to add x, if this is xy, we need to add x how many times? So basically, first we have x, in the next time we'll add x plus 1. So basically, then we'll add x plus 1, and then we will add x plus 2. And how many times we need to do this? We need to do this y times. Okay, so with this approach, we will be able to find this particular index. Okay, let's say, I hope this is clear. So basically, finding this index is clear to everyone. Okay, now let me just rub all of this. Okay, now let's try to find out. So basically, now what we are given, let's say this was any particular index, and this was any particular index, and we had to find out the sum of the minimum path, sum of the maximum sum of the path. Okay, so basically one path is 5 plus 8 plus 12 plus this value, one path is this plus this. Okay, now how to find out the maximum path? For that, there's a very easier technique. Whenever something comes onto grid, what you do is you just take this particular value, which are the very first values. We have 1, 2, 3 and 5. Now we know that to go from 1 to 5, there are only two paths. Okay, one is this path and the other is this path. Let's calculate both the paths. So this path gives us 1 plus 2 plus 5, and the other path gives us 1 plus 3 plus 5. This has a sum of 8 and this has a sum of 9. So with this, we can say that it is beneficial to first move in the downward direction and then in the right direction. So let's say if we have to move from this 1, 1 till, let's say, any index till this index, we first move in the down direction and then in the right direction. And that is how we are going to find out the minimum distance. Okay, now we know what path to choose when we have to find out the maximum sum. Okay, and we also know the initial value. Now what is left? So basically, let's say we had to move from this particular index to this particular index. Using our previous formula, we were able to find out what value do we have here. Now we need to find out this 9 and this particular value and this particular value. Now how to do that? So basically, we know that this is nothing but x1. Okay, let me just rub everything and draw it again, because I think it has become very messy. Ishank says on Telegram. Okay, cool. Let's just hope that you people are not cheating there. Okay, cool. Let's say this was any matrix, and let me just write the values again. 1, 2, 4, 7. We have 3, 5, 8. We have 6, 9, 10. Let's say we want to move from this particular index to this index. Okay. Now, what is the very first thing we need? So basically, let me write the other values as well. So basically, this will be 14. I hope I'm right here. Yeah, this is 14. The next value is actually going to be 19. Next value will be 25. Okay. Now, if you see, this is 1, 2, 3, 4. This is 1, 2, 3, and 4. Now, this is x1, and this is x2. And if you see, okay, cool. Now you need to see, like, what is the increment value here. If you see, the increment value here is x1 and this is y1. Okay, so basically when we move down in the very first iteration, the increment is x1 plus y1, x1 plus y1. Okay, cool. So if you are at 5, you just have to run a loop from x1 till x2, find out the very first increment, which is x1 plus y1, and then keep on adding plus 1 plus 2 plus 3 till you reach the very end. So basically this was x1 plus y1. This distance is x1 plus y1 plus 1. So x1 plus y1 is 4, and this is x1 plus y1 plus 1 is 5. and as you can see, there is a difference of 4 and there is a difference of 5. Okay, so find these values differences, add them to the previous value, and find the sum of this path. Now we are left with finding the value sum of 19 and 25. Now how to see like what is the increment value here? Okay, now if you see the increment, okay, I myself forgot like what is the increment value. Okay, so we have an increment of 5 here, we have an increment of 4 here, and here we have an increment of 6. Okay, cool. So basically if you see, the increment was starting with 4, okay, and this is y1. So basically the increment after this value is actually going to be what? X2 plus y1 minus 1. If you see, this is x2. So basically x2 is the very first increment, and then y2 minus 1 is number of increment that we have already done. Since we are at 2 only, that means one increment has been already done. Therefore the next increment is actually going to be x2 plus y1 minus 1. Now this is the very initial increment that we know. Now again we'll run a loop from y1 till y2 and keep adding plus 1 to this increment and find the values and then find the total sum. Okay, cool. I hope this is also clear to everyone. Okay. Anu says x plus y minus 1. For what are you saying this? I don't understand. So this had an increment of 3 and this had an increment of 5, which is okay. Anubhav is saying that we can directly find, yeah, actually this is that only. If you see, x2 is nothing but x of this particular index and y was nothing but y of this particular index and then minus 1. So yeah, you're right, Anubhav. We can just say x plus y minus 1 if we are moving in the right direction, and if you're moving in the downward direction, then we can just say x plus y. Okay, cool. I hope this is clear to everyone now. There were a couple of things involved, but I like this is made more about a implementation problem. So I'll just show you my code. I am not sure if this is the best code that you will find. Is this the code? Yeah, this is the code. Okay, so I won't spend much time into it because I spoke everything about it. Okay, so value is x1 into, so basically this is the very initial value that we are finding. Okay, then I'm just finding the increment values, adding it those increment values, and what okay, then okay, this is where I'm going in the downward direction, this is where I'm going in the right direction. Now you can write many different variations of this, like how to write this implementation, so I won't explain everything in this. I've explained everything on the board, and this is the exact same thing only here. Okay, so just spend some time if you're not able to understand the code and like see like what is happening. All right, cool. Let's move on to the next problem now, which is, I hope this is clear to everyone. We have 23 people watching. Can I have like a few clear or yes from people so that I know like people are able to understand the problem? Or you can just like the video as well. I will get to know. Okay. I have some people asking like where do I like how they can find the code. So what I'll do is I'll write all like what should I do? You can either go to my profile and find the code, but I haven't submitted them from my profile, so I'll just submit all of the problems after this. Or you can also go to my Discord, and there I'll post all the submissions. So let me do that right now only. Okay. So I don't have a separate channel for this particular, what do we say? I hope Discord is visible to everyone. I don't have a separate channel. So let me just make that now. And how do we make that? Okay, just give me some time. I'll make that in the meanwhile. Okay, cool. Let's move on to the next problem. I'll make a channel for this particular contest, and then I'll like paste all my submissions there, and you can join this channel. Okay. Okay, and yeah, how to join the channel? Share invite. Okay, you can just write this bit.l. Okay, I forgot this as well. It is just a second. Okay, bit.ly slash Naman Bansal 013. This is my handle on every social media. Okay, cool. So you can just type this in the browser and we'll go to the invite. Okay. All right, cool. Akash says share invite. Yeah, this is the invite. Dipansh says nice explanation, sir. Okay, thank you. Okay, let's move on to the next problem, which is chef and arrays. Okay, I don't think this will take much time now. Okay, chef is playing a game where he has an array A of n integers. Dipankar says GitHub. Yes, GitHub is a really nice idea, but I don't think like making separate repos for every okay. We can do that as well. I'll do that after the contest. Okay, I like after the stream. But for the meanwhile, you can find all my submissions on the Discord. And let me do one thing only, since everybody is asking. Let me like paste all my submissions here only in the general only for now. I don't think it's a very good method, but for now, let's do that only. Or yeah, general only. Cool. So this is the code for marathon. Uh, okay. Okay. Is this better? Like, I don't really know. Okay. For now, let's stick to this only. The next was vaccine drive. This is the code for vaccine drive. Then the next is this one. Okay. So if the next problem had the name of the last problem. Okay. This is the code of the last problem. And then okay, this is not done yet. Okay, I'll like share all my codes here. Okay. You can just use the invite, which this now bit.rel/number013. I am not able to paste that in the chat. That's why I'm not pasting it. Okay. So just use this, type this somewhere, and then you'll get here. Okay, cool. All right. Let's move on to chef and subarrays. Okay. Okay, from next time I'll make a GitHub repo or something and I'll paste all my submissions there. Okay, so it's easier for everybody. Now, Chef is playing a game where he has an array A of n integers and an integer k. Let me bring myself here. Okay, cool. Okay, and an integer k. He looks at every subarray of length k and writes its sum on a piece of paper. If a number appears on the sum of as a sum of multiple subarrays of length k, then he only writes down the number once. Chef is lazy and doesn't like the right numbers. You, being a friend of Chef, want to modify the numbers such that Chef will only write one number on this paper. In one modification, you can choose any index I and replace AI with any number. You need to find the minimum number of modifications required. Okay. So there's a very simple idea behind this problem. Let me explain the problem first. So basically, we are given this array and we are given a k. We need to find the sum of every subarray of length k. So this will be one subarray, then this will be one subarray. Okay. Then we'll have one subarray as this, then we'll have one subarray as this, and so on. So basically, this is a window. We are just sliding this window. Let's say this was what? X1, X2, X3. Okay, let's have three values here only. So, yeah, cool. This is right. Okay. Now, this is X4, this is X5. Okay, let's see what we want to do. So basically, let's say this is sum 1, this is sum 2, and this is sum 3. Okay, x6 and let's say x7 as well. Okay, now sum 1 is actually equal to x1 plus x2 plus x3. Sum 2 is actually equal to x2 plus x3 plus x4, and sum 3 is actually equal to x3 plus x4 plus x5. Okay, now we want that this sum 1, this sum 2 and this sum 3 should be equal. That is what Chef is saying, that he doesn't want to write multiple times, so every sum value needs to be same. Okay, to make this value and this value same, we know that x2 and x2 are common, x3 and x3 are common, therefore x1 and x4 are different. That means that x1 should be equal to x4. Now let's come on to sum 2 and sum 3. This tells us that x3 and x3 are common, x4 and x4 are common, x2 and x5 are different. That means x2 should be equal to x5. Okay, now we also want sum1 and sum3 to be equal. Now x1 is equal to x4, therefore this x1 is equal to this x4. x2 is equal to x5, x2 is equal to x5. x3 is common, therefore it is already same. So sum1 and sum3 are become already same if these values are done. Okay. Similarly, we'll have sum4. Let's write one last sum. This will be x4 plus x5 plus x6. Okay. I think I did something wrong. 3, 4. Okay, this should be till here only. Cool. Okay. Then we have sum4, which is actually this. Okay. Now sum4 tells us that I need to be similar with every other sum. Okay. Let's see. So if we compare it with this one, we say that x3 should be equal to x6. So x3 should be equal to x6. Okay. And if you just see, every other value is already same after this operation. I think so. Okay. So let me show that with sum3 we have made it equal. For sum4 and sum2 to be equal, x4 is common, x3 is equal to x6. So this is equal to this, and x2 is already common with x5. And similarly, this is already same with this also. Let's write one last sum 5. This will be sum 5 plus x of 6 plus x of 7. If you see, if you want to compare this and this, it tells us that x5 and x5 are common, x's and x's are common. x4 should be equal to x7. Now we know that x4 is equal to x1 as well. So basically we can just write these values should be same. Now I think you are able to see the pattern. So x1 should be equal to x4, should be equal to x7, should be equal to x of 10, and so on. Similarly, x2 should be equal to x5, should be equal to x8, and similarly, and this also. So basically every kth value, so basically if this was, basically we took k as 3. So every kth value should be equal. So if we took x1, then x1 plus k, which is actually k is 3 here, therefore x4. Then 4 plus 3 is x7. Then 7 plus 3 is x10. And that is how this pattern is going to follow. So basically now we have some sets. This is one set, this is the other set, this is the other set. Okay. So we have these sets. So let's say this is one set, this is second set, this is third set, and so let's say in total we had 4 sets now, and now we wanted every value in these sets to be same. Let's say this comes out to be A1, this to A2, A3, and A4. Now, how to make every value same? Okay. The way for doing that is we first see what is the maximum count of any value. So maybe x1 and x7 are already same. If x1 and x7 are already same, that means it's better to make x4 and x10 as x1 only. Instead of making every value to some other value, since we have to minimize the operations, we can actually make x4 and x10 equal to x1, and x7 was already equal to x1. So basically in every set, you now need to find out the maximum count of any particular value. Then so basically we have the maximum value, and then you take the size of that set, subtract this maximum value from that, and that is the total number of operations we need for this particular set. And similarly for the other set, and similarly for the other set. So let's say in this set we had 1, 3, 1, 5. Now we know that 1 is occurring 2 times. Therefore what we'll do is, so maximum count is 2, the total size of the set is 4, therefore 4 minus 2 is 2, therefore we need to make 2 operations. So basically, and those 2 operations will be changing this 3 and changing this 5. Similarly for the other sets as well. Okay, so I hope the approach is clear to everyone. Can like people confirm in the chat if it is okay, cool. Okay, let me show the code now. There isn't much in the code again. So what I'm doing is I have this n and k scan. Okay, after that I have this array. Now what I do is I actually have this 2-dimensional map. So basically I have k maps actually. Okay. So if you see, what I'm doing here is I actually made k maps. So basically I have m of 0, I have m of 1, I have m of 2 till m of k minus 1. Okay. Now what I'm doing is in every map, so basically, when I scan the array, I do I percentage k because I know 0 if k is, let's say, 3, I know that 0, 3, 6, 9 should all be included in one set. So what I do is, if my I comes out to 6, let's say, so 6 percentage 3 is 0. So with this, I get to know that I need to insert this in 0th set. Okay. So what I do is m of 0, okay, this comes out to be 0. And then in this, I actually insert the value at this index. Okay. So array of 6 get inserted into this map. Okay. So with this, I actually get all these sets. I'm actually counting all the values here. So basically, a of 6 will get incremented here. Okay. And similarly, so in every set, I have all the values, count of all the values now. Okay. Now what I do is I run a for loop and I just find out the maximum value in every set. So in every map, I'm checking the maximum like count, and then I am also like adding all the counts, and then my answer is actually sum minus this maximum value. I add this for every set and then I print the answer. Okay, I hope this is clear to everyone now. Okay. All right, and similarly, I'll just put this in the Discord as well. Okay, what is the name of this problem? Chiffon subarrays. Okay, so this problem. Okay, cool. Let's move on to the next problem now, which is what? Okay, before me moving to permutation swaps, I'll actually share double burgers. Okay, because this problem is actually like, if we go to div 2, let me just open up div 2. If you go to div 2, you will see that this problem is actually, double burgers is actually above permutation swaps and div 1 as well. So I'm actually going to first tell how to solve double burgers, and then we'll move on to permutation swaps. Okay. Okay, cool. Okay, let's move on to double burgers now. Okay, sorry. Okay, so you have taken an eating challenge from chef, and now you have to eat exactly Y burgers. You will eat in the following way. In the first minute, you will eat exactly X burgers, and in every minute after that, you will eat exactly twice the number of burgers you ate in the previous minute. Okay. Since you are get tired of eating, chef also allows you to take a break for eating for exactly 1 minute. Okay. So basically, we eat for some X1 minutes, then we take a break of 1 minute, then we again eat for X2 minutes, and so on. Then we again take a break, and so on. Okay, cool. Now, when you start eating again and okay, in the first minute you will eat exactly X burgers. Okay, so if we eat X burgers, in the next minute you will eat 2X, then we'll eat 4X, then we'll eat 8X, and so on. Now they are saying that when you start eating again after taking a break, your eating streak resets. In the first minute after the break, you will eat exactly X burgers. So basically, again we start from X, 2X, 4X, and so on, and similarly in this as well. Okay. Now let A1, A2, AK be the lengths of eating streaks in minutes. So basically, the streaks were X1, X2, and so on. Chef wants that these should be unique. Okay. Find the minimum number of minutes you need to eat exactly Y burgers, or determine if it is impossible to do so. Okay. Now, let me just explain something. So let's say this was one streak. Okay. So basically we had X. So basically, what are the total number of burgers eaten in this particular time? We ate X plus 2X plus 4X plus 8X and so on. Okay. What if I take X common? I get 1 plus 2 plus 4 plus 8 plus this. Okay, similarly in this also, if I take X common, this becomes 1 plus 2 plus and so on. So basically, in every session, I'm actually eating a multiple of X burgers. Okay. So the very first thing that I can do is I can just divide my like total burgers. Total burgers are y, I think. Yeah, total burgers by x and see if it is divisible. That means I might have an answer. If it is not divisible, that means there is no way I can have an answer. Okay. So that is the very first thing that you need to handle. And if you see, if you just take this x as common, this is the like number of burgers you are eating. So basically, even if you have y, you can first divide this y by x. Okay, and then we can just assume that x is 1 now. Okay, so that is the very first thing that you need to do. You need to change x to 1 by first dividing y with x. Okay, now one constraint is like removed, that there are values of x as well. Now x is 1, therefore we do not need to consider any x. Okay, now what is the next thing that we need to see? Now we know that, so x is gone now. We know that in every like session we are eating 1 plus 2 plus 4 in this sense. So this is a GP and sum of a GP. Okay, so basically if you see, we might have a session in which we only eat one burger, or we might have a session in which we eat 1 plus 2 burger. We might have a session in which we eat 1 plus 2 plus 4 and so on. This has a sum of 1, this has a sum of 3, this has a sum of 7, the next will have a sum of 15. These values are nothing but 2 to the power minus 1. 2 to the power 2 minus 1, this is 2 to the power 3 minus 1, and this is 2 to the power 4 minus 1, and so on. Next will be 2 to the power 5 minus 1. Okay, cool. Can anyone give the Discord link? It's actually bit.ly slash Naman Bansal 013. Okay, so you can just write this in the browser and you'll go to the invite link. Okay, all right. So this is the so basically these are all the values which we can, these are all the sums that we can have in one session. Okay, now what is the next thing? So if you see, and now we are given that every session should be unique. Okay, so basically we can, like, there can only be once that we can use this session in which we ate 7 burgers. There can only be one session in which we ate 15 burgers, and similarly for 3, 1 and other sessions as well. Okay, now if you see, we can actually write a greedy approach here. Okay, let's say in total we had y burgers, and let's say we took all these values and we put them in a like set or vector. Okay, we had this particular set. Now we need to find the minimum number of minutes. Okay, now to do that, we will actually first find out the upper bound of this y, or basically we are trying to find out the very value which is just lesser than or equal to y, because in the very first session it is beneficial for chef to eat all those burgers. Okay, so basically this will have 1, 3, 7, 15 and so on. Okay, so basically the very first thing that we will do is we'll first find out the very session in which the value is less than equal to y. We'll subtract that particular value from y. Now we are done with one session. We also need to find out the index of this value. Okay, so basically if this was 1, this was 2, this was 3, this 3 tells us that the chef took 3 minutes to eat this many burgers. So let's take an example. Let's say y was 21. If y was 21, then we can say that this y would actually come to this 15, and we would subtract this 15 from this 21. So 21 minus 15 gives us 6. Okay, let me write this little, let's say this is 20 here. Okay, so that we have an answer. Okay, if this is 20, 20 minus what? 15 actually gives us 5. And the index of this is 4. Therefore, our answer says that I have consumed 4 minutes by now and eaten 15 burgers. Now I need to take a break. So we add plus 1. Now we again like come to the same thing. We have 5 burgers left. We first find out the largest value which is lesser than or equal to 5, which is this 3. We say that in the next 2 minutes, so we'll add 2 minutes, we can eat 3 more burgers. Okay, so we write what? 5 minus 3, which is 2. Now we are left with 2 burgers. Now we do the same thing again. We say that we can eat 1 burger in 1 minute. So sorry, we first had to take a break, so we wrote plus 1, and then we again say plus 1 and say that we can eat 1 burger in 1 minute. Okay, so basically 2 minus 1 gives us 1 burger now. Now we are left with one burger, and if you try to find the upper bound, basically the maximum value which is greater than this one, lesser than equal to this one, we see that we again get this one. And if you see, this one has already been used. If this has already been used, that means there is no way we can eat 20 burgers. Okay, had this 20 been 19, okay, if this 20 had been 19, this one would now be 0, and we would have just said that this is the answer. Okay, so it's a little confusing, but so basically I'll just tell the steps. So basically first you have to realize that there's no significance of x. Okay, the x is only used to see if the answer is -1 or not. Okay, now we divide our y with x. The next thing we do is we actually generate this array in which we have all the sums of all the sessions that we can take, and then we just have a while loop to go for the greedy approach, that we first take the maximum length, like the biggest session of burgers which we can consume, and then so on. Okay, so I'll just show the code and maybe things will get better with that. Okay, so the problem is burger. Okay, so if you see, what I'm doing here is, first I'm generating the vector, because we have to do that like outside of the while loop for test cases. Okay, so I'm generating this vector till 2e to the power 18, because the maximum number of burgers are till 10 to the power 18. Okay, so I first inserted all the values in this vector. The next thing I did was I had x and y. Okay, let's leave this visited for now. Now I checked if y is divisible by x. If it is divisible, then I just divide it, otherwise I say the answer is -1. Now what I do is, while my y is greater than equal to 0, I find out the upper bound in this particular v. Okay, so for 20 we found that 15. Okay, now I find out the index of this, which is nothing but it minus v of begin. So I find out that 4. Okay, now what I did is, okay, so basically if we find the upper bound, we are actually going to get 31. The index is 5, and now I actually, like, it minus minus is going to give me 15. Okay, then I subtract this 15 from my 20, which gives me 5. Okay, now I mark this node as visited, that I have already processed this particular index. That means if I ever come across this index again, that means my answer is not possible, because we have already used that particular index. So if that is the case, we just make answer equals to -1 and break. Otherwise, we mark this index as visited, and we add this to the, we add this index to this answer, that we need to take these many steps. Okay, so basically for 15 we had to take 1 plus 2 plus 4 plus what, 8. Okay, so we had to take 4 steps, and this is 0 based indexing if you see in the code. Okay, so basically this 4 we had to add, that means 4 steps are taken, 4 minutes are consumed. And now if my y is not equal to 0, that means if I still have burgers, that means I am going to take a break now. So I add 1 to the answer, and in the end I just print the answer. Now this answer can either be -1 if we had broken out of this loop, otherwise we'll have the total number of minutes. Okay, I hope this is also clear to everyone. There were some things to notice in this, so I hope it is clear to everyone. This problem was not included in Dev 3, so maybe like some of you might not be knowing this problem. But yeah, do attempt this problem. This is a really good problem. Okay, and for Dev 2 folks, I think you are able to get the problem now. Okay. Okay, I hope it's okay. So we are at 1:30. Okay, let's do the last problem for today, which is permutation swaps. Okay. Okay, so let's see this problem. Now, a permutation in array consists of n distinct integers from 1 to n in arbitrary order. Yes, that is the general definition of permutation. Now, Chef has two permutation arrays A and P of length n. Okay, so there are two permutations. One is A and one is P. Okay, of length n. Chef performs the following three types of permutations on array A. So this was a permutation and this was also a permutation. What he did was, if we are given operation 1, then he said that B of P of I should become A of I. If it's an operation 2, then we need to swap values at x and y. So basically A of x and A of y are swapped. Okay. Otherwise, we just need to print A of X. These are the three cases that we are given. Akash says int answer equals to 4 answer, int answer equals to C answer. Question 2, what's wrong in this? Akash, I am not sure I can go back to that problem now. Maybe you can like post this in the Discord somewhere and maybe someone will help you out. Okay. Okay. So these are the three operations that we are given. Now we need to like, okay, what a shift wants. Okay. Now for every print operation, we need to like print the values. Okay. Now if you see the queries are till 10 to the power 5. Therefore, for every print, you cannot like swap all the permutations because like that will be very big. So a swapping, so basically doing this operation will take O of n. This operation will take O of 1. So if we have like 10 to the power 5 permutations to swap, then this will be 10 to the power 10 operations, which is not feasible. Okay. So for every query, we need to come up with a method that we can do this in O of 1 or maybe root n or something. Okay. Now, let's look at the test case. Or what I'm going to do is I'm actually going to take a custom test case. Okay, I'm not going to take the test case given in this particular problem. Let's take a test case in which we have 5 values. Okay, so let's say the test case is 4 1 3 2. Okay, 4 1 5 2 3. This is my A, and my P is 3 2 5 4 1. Okay, this is my P. These are any random values that I came. Okay. Okay. Now, the operation that we need to do is B of P of I should become A of I. So essentially what they are saying is, if this is my B, like this is the new array that I get generated, P of I, P of 1 is 3 right now. So basically B of 3, which is this, should become A of 3. Okay, sorry, P of 3, sorry. P of 3 is this 5. This 5 should go to A of what? 3. So basically this 5 should go to this 5. So basically this 5 will come here. Again, what? Sorry. I was actually for 3. Okay, just a second. P of 1 is actually 3. So basically B of 3 will become A of 1. So basically B of 3, which is this, will become 4. Now coming on to the next index, 2. Now P of 2 is 2. Therefore B of 2 will become A of 2, 1. So you can see that basically 5 will become 5, 4 will become 2, 4 will become 2, 1 will become 3. Okay. And P is 3, 2, 5, 4, 1. Let's do this again. Okay. Now the new array will become, for 3 we will have 3, for 2 we will have 1, for 5 we will have 4, for 4 we will have 2, and for 1 we will have 5. Okay. Similarly, let's do this again. Okay, there's a reason why I'm doing this. I'll explain that later. So basically now 3 will become 5, 3 will become 5, 2 will become 1, okay, 5 will become 3, 4 will become 2 only, and 1 will become, sorry, I did something wrong. 2 was supposed to become 1, 5 was supposed to become 3, okay, and 1 is going to become 4. Okay, if you see, this is actually similar to this. Or maybe you won't get this similar. Basically what I'm trying to say is, let's see where this 4 is going. This 4, okay, so basically you're writing for 4. This 4 in the starting was at index 1, then it moved to index 3, then it moved to index 5, and then it again came back to 1. So basically this is the cycle in which 4 is moving. Let's look at 1. Where is 1 moving? 1 is actually, sorry, so this is basically the value at index 1. Value at index 1 started from 1, moved to 3, then 5, and then again at 1. Now let's look at the value at 2. Value at 2 is actually moving, okay, it is not moving actually. It is always at the same, okay. So basically 2 remains at 2 only. Then 3, we can see that 3 is at here. So basically 3 is actually moving from 3, then it moves to 5, to 1. So basically this cycle only. Okay, then 4 also is not moving, and 5, if you see, is actually in the same cycle only. So basically we have 5, 1 and 3. So basically what I'm trying to prove is that every like index has a cycle in which it is going to move. Okay, so let's say that whenever we ask to permute, whenever we are asked to permute, we for every index we have these cycles. Okay, for every index we have these cycles. We just move one ahead and find out the values. Okay, but again, this is going to take O of n. Now, let's see. So basically, what if, let's consider a case that I asked you to permute, then I asked you again to permute, then I asked you to swap, then I again asked to permute, again asked you to permute, again asked you to permute, and then I asked you to print a particular value at index. And let's say this swap was for x only. Okay. So basically what we can see is the value at this x needs to be permuted 3 times. We are trying to backtrack everything. Okay. So basically plus 3 that we need to permute 3 times. Now we see that whatever value we had at x was actually coming from y. Okay. Now what we need to do is we need to find what value was present before like every permutation. So basically before doing these two permutations, what was the index of this particular y? Basically what was this y? Because this y is like what was the value present at this y, because that value is now present at x, and that is the value after doing 3 permutations is present at this particular x. So basically we need to, for every swap we need to find a way that we can actually like transform these pointers. Okay, let me like show the code and then explain this again, because basically there are a couple of things to understand in this, and it will get a little easier. Okay, let me just, okay, this is the code. Okay, so basically what I'm doing in the starting is that, so I actually like scanned the complete array and I made a, okay, this is just cleaning. Okay, then what I did is after scanning what the p array, I'm actually like storing the indexes there. So basically which value is present where. So mp1 stores which value at this p is at which index. Okay, then I'm just running a DFS, and using this DFS I'm actually generating all the cycles. Okay, so this is what I'm doing, and basically how I'm doing this is basically I have the name as ADJ, and this ADJ0 has the first cycle, this ADJ1 has the second cycle, this ADJ2 has the second cycle, and so on. So basically I have all the cycles. Okay, now what I'm doing is I'm also like storing for every particular like index. So basically for 3 what I'm showing is in which cycle it is containing. So is it in 0, is it in 1, is it in 2, and I'm also like storing the index where it is present in every cycle. Okay, so let's say if 3 was present here, this 3 would have 0, that it is present in cycle 0, and let's say the index was, let's say this was 2, 3, 4, this was the complete cycle. So basically I'll have 1 here, that it is present at the first index. So this is what I'm generating through this DFS. Okay, alright, so what is the next thing? So basically if I ever get a query of type 1 which is permute, I just added that. This is just like basically what I wrote here, that we have to make 3 permutations. Now let's see what happens whenever we get a query of type 2. Now I know that I have x and y. Now I need to find out the real values at x and y. Okay, how to do that? So basically I need to find out what value was present at x, and more importantly I want to find out what value was present at y, and I need to swap those two values, because I know in my new permutation, like if these were the two values, if this was x and this was y, like this was x index and this was y, I know that this value now is actually, after like this swapping, is now going to be present at this. So how about I initially place this value here, and then all my permutations will give me the right value. Okay, so maybe some of you are not able to understand this, so just go back into the video and try to like understand this. So now I need to like find out what was the index of this x before these two permutations. So basically what I do is whenever I get a query of type 2, so first I had permute, so I did +1 in total, then I had this permute, I did another +1, so my total right now is +2. Now I need to find out the values of this x and y. I know that how to find that? So basically, I know that for this x, I have a map in which I have in which cycle it is and at what index is it in. So basically, let's say this x was here. Now, if this has been permuted 2 times, that means I need to move ahead 2 times in this cycle. So one step and the other step. That is what I'm doing. So basically, these are some. Okay, I'll not explain this. This R1 is actually the like row. Basically, this is the row. Okay, and this C1 is actually the index where it is present in that particular row. And similarly for Y also, I'm finding this value. Now I have the size of both the cycles, and now I'm just rotating these two values. So basically, first I like check with total. Okay, so this is something that you can understand. Okay, so basically I rotated this total number of times, which was right now 2. And I found out the updated values of these two indexes, and then I swapped both these values. Okay, then okay, so basically this swapping is done. Okay, I have no significance of the swapping. I have completely erased the swapping because I have already swapped the values in the initial array. Okay, now I have permuted 2 times. Now I again get permutation of 3 times. So basically my total now becomes 5. Okay, now when I get a query of type 3, which is print, what I do is I again find out what is the like cycle number of this and what is the index of this. So I'm doing the same thing, R1 and C1, and then I just permute it. So basically move how many total times in this cycle. Okay, and when I do that, like I find that I index of that particular, like I find the updated index of this x, and then I just print that particular value. So there were a couple of things in this like problem. I don't know like how many of you were able to understand it, but yeah, just if you're not able to understand it, just go a little behind in the video and you will definitely be able to understand it. So basically the idea was, for permutation, we first realized that there are some cycles that are being made. So for every index, we stored in which cycle it is in, and then in that cycle, which index it is in. Okay. Then for every swap, we already swap them in the array, so that like we can completely nullify those swaps. And then if we get a print statement, then we just like go to the row number and the column number using that cycle, and then we just iterate that many times. Okay, not iterate, we just skip that many times. Okay, so there were many things to explain on this. I guess it is clear to everyone. Okay, if not, you can just go back in the video and see it. Okay, and I'll just paste this code as well. What is the name? Permutation swaps. Okay, permutation swaps. Okay, just a sec. Okay, just a second. I need to make a new message. Permutation. There seems to be some issue. Okay, just a second. Let me delete these. Delete. And again delete. Swaps. What is the issue with? Okay, 2000 characters. The code can. Okay, I won't be able to like paste this code then. Okay, let's skip this one then. I'll make a GitHub repository or something for next time so that like you can all see the code as well. Let me just try this. Okay, I have sent this file. Could not read this file. Okay, this is possible. Permutation. So this has gotten a little messier. I'll like clean everything from the next time, and I'll make a GitHub repository or something. Okay. If you have any doubts in anything, you can just post it in any of the channels. Someone will definitely like tell you the mistake or anything. Okay. Okay. I think that's enough for today. It's already 1:43, so I think I should end it. Okay. Bye. Thanks, guys.